Well, I welcome you all to the last lecture of this course, that is lecture 3 of week 12. So, in this lecture, we will be studying how to write simple CNC programs. So, to write simple CNC programs, we first know what is the meaning of G and M codes that we will see. G and M codes are nothing but the preparatory and miscellaneous codes. What are the various building blocks of a typical program? So, what is the structure of a CNC program that we will see? There are various important functions which are used to develop a CNC program, and these are the canned cycles, tool length compensation and tool radius compensation. After that, we will solve certain problems, we will write simple programs to understand the structure of a program in a better way. So, let us begin the last lecture. Well, after studying the CNC machines, their configurations, let us start the CNC part programming. As far as the automated computer-aided manufacturing systems are concerned, it is very essential for an automation engineer to know how the CNC machines work that we have seen in the previous lecture. Now, in this lecture, we will be studying the CNC programming at the preliminary level. To understand the CNC programming, we are taking a very common example, widely used equipment, that is CNC milling center. So let us look at the CNC program structure. The CNC program basically has 4 different types of elements. The program itself is made up of various blocks. The blocks are made up of words, and words are having characters. Character is considered as the smallest unit of the CNC part program. The characters are nothing but various alphabets that we used, various numerals that we utilize, and various special characters that we consider to write a typical CNC part program. When we combine together various characters, the word is formed, and when we use the words in a logical order, we are getting a block. So by clubbing together, by getting various blocks together, we are generating a program, and that program is carrying out the CNC operation. It may be turning operation or the milling operation. As I mentioned, the word has alphabets and numerals. Each word is starting with a capital letter and followed by a numeral. So this is a typical construction. Each word is having a capital letter and it is followed by a numeral. So for example, we are having G01. So here the G, this G01 is the word, and it is comprising of the alphabet G and the numeral 01. Or we can have something like this. So this is also one word, M06. M is the miscellaneous code word and 06 is the number, or T01. T01 is the tool number 1. The words are representing the axis positions, the feed rate, speed, the preparatory commands and the miscellaneous function. The G commands are the preparatory commands and the M commands are the miscellaneous commands. The multiple lines of instructions which are considered as blocks are given to the machine control unit, and machine control unit will execute these blocks one by one and the program will be executed. If you look at a sample CNC program, it has basically 3 sections: the initial command section, the main section, and the third one is the end command section. So in the initial command section, we are basically providing the program number, the safety instructions, the safety preparatory codes, such as cancelling of all the activated cycles by previous program. In the main section, we are providing the information about the interpolation. We are providing the information about the position, distances, change of the tool, coolant on, speed, regulation. So all these fundamental instructions will be given in the main section. And at the end, the cancellation of the cycles. Whatever the cycles are made on during the main section, that would be cancelled at the end, and the tool will ask to go to the home position, and at the end we are completing the instruction by writing the program end command. A typical CNC program can be seen on your screen. So it starts with percentage sign, and that gives the start of the program. The controller will look at the percentage sign, and accordingly it will start executing the program. Each program has a number and ID. So here the number and ID is O0012. It starts with an alphabet O, and then the number has been given. Then the initial commands are there, like G21, G40, G80, G49. Then selection of the tool, that is T01, and change of the tool by using M06 command. Afterwards, the main section comes over here. This is the main section, and here we are giving the instruction about the interpolation, that is a linear interpolation in rapid mode, as a clockwise or anti-clockwise interpolation, variety of cycles that we are using, such as the drilling cycle, and at the end we are having the cancellation section. All the cycles would be cancelled, and afterwards we are asking the tool to go to its home position by using G28 command, and by using M30 the program will stop, and at the end of the program again we are putting the percentage sign. So this is a typical program. This is a sample CNC program. There are various controllers such as Sinumeric, Mitsubishi, Fanuc, and these controllers are using similar programs. Their syntax may be little change, but more or less the structure of the program is same. The syntax may be little different. So in the CNC program, particularly the G word is given for the preparatory command, which will prepare the machine tool to carry out certain operation. So as I mentioned, the preparatory command G01. So the meaning of G01 is the linear interpolation with the provided feed. Linear interpolation at given feed. So once the MCU reads this word, the word is G, that means it will understand that it has to get ready for what? For G01. 01 means the linear interpolation. The MCU has to be ready to carry out the linear interpolation with the data given after that G01 command. So consider if you are having G01 X20 Y20. The meaning is that the controller should get ready, or it should execute the linear interpolation to reach X20 Y20 from its previous position. So in this way, the preparatory commands are asking the controller to execute the specific task based upon the numeral value provided along with the G letter. Then we are having the address M, and that is specifying the miscellaneous function, or it is also called as the machine function. Various auxiliary functions which are to be done during the CNC machining operation. These are related to the rotation of the spindle, change in the gear range, automatic tool change, and coolant operation. So these machine functions would be carried out by the address M. So there are numerals available, M06, that is the change the tool. The G and M codes are controller manufacturers specific. These are changing from the controller to controller. Now, to understand the method of programming, let us take an example. On your screen, you can see a mild steel plate, top view of a mild steel plate, and we have to drill holes on this mild steel plate. The dimensions are given in inches, 11.18 inches width and around 17.4 length, the mild steel plate. There are around 35 holes and the diameter of the hole is around 0.5 inches. The variety of distances are provided on your screen. So we need to write a program to drill all these holes by using CNC Machining Center. The thickness of the mild steel plate is given 0.4 inches. So now when you got such kind of problem, then you have to first plan your activity. So in which format, in which way you will be trying to drill the holes, what would be your tool path, what kind of tool you will be utilizing. Here you have to finalize the details about the cutting tool, the feed, speed and tool path. After finalization of this information, then you can start writing the program. So tentatively here we will decide that we will first drill this hole and then we'll move in the upward direction. After drilling this hole, we'll move to the next column, so the column number 2. We will drill these holes and then we'll move in downward direction in column 2. We'll reach here, then we will move to column number 3 and then we'll move in upward direction in column number 3. We'll reach at this point, then we'll move to the column number 4, then we'll follow this path. The tool path has to be decided. Then the last column, the column wise movement we are going to follow here. So it's not essential that there is always to follow the path shown here. So you can have the row wise zigzag movement can also be followed. It all based upon the optimized way. So based upon this tentative planning, let us write the CNC part program. So on your screen you can see the CNC part program. So variety of codes are written in a block-wise manner. So before that, let us look at what are the various G codes that are used in milling operation. On your screen, the G codes are listed from G00, G54. Then we are having the next set of G code from G55 to G99. We are also having the miscellaneous or machine code for milling operation. This can be seen on your screen. So when I'm referring to the CNC part program, I request you all to get a printout of these codes and keep with you when you are reading or when you are learning the G code and M code or CNC part programming. The notes provided in the course will have these codes. Fine. So let us look at the CNC part program. So we are having the start of the program, then the program ID. This is ID and number, and we are having the initial commands. So initial commands can be seen on your screen. G20. G20 is input in inches. So we are giving here input in inches that need to specify. Then we are selecting the XY plane. For that, G17 is to be used. Then we are using the preparatory commands such as G40. G40 is cutter compensation cancel. We will see the meaning of cutter compensation in the next example. G80 is can cycle cancel. There are certain drilling cycles or can cycles which might have activated, or the previous program might have not deactivated certain CAN cycles, we need to just cancel them. It is very similar to the clear screen command which we use in our general programming. G49 is tool length compensation. G90 belongs to, or it represents, the absolute programming. So at start we are using the absolute programming. We are providing the distances in absolute manner with respect to the origin, that is 0 0. Then the next command is G92 XYZ. It is related to the part program 0 setting. Every machine tool has its own reference point. It has its volume, and that volume has its own reference point, and every part, every workpiece is having its own origin. It is having its own coordinate system. So when the part is fixed on the machine table, we need to communicate to the machine tool that its location in the work volume. So for that purpose, G92 with XYZ offset values are to be communicated with the machine tool. We will be seeing this in the coming slides. M06 is the tool change, but which tool has to be utilized by changing the existing tool in the spindle. So M06 T01 means the existing tool in the spindle will be replaced with T01. Then the preparatory command with respect to the rapid movement, that is G001. So rapid movement G00 means there is a linear interpolation with maximum possible feed rate that machine tool can have. The rapid movement with maximum possible feed rate, that feed rate of the machine tool. However, for our machining operation, we do not require that maximum the feed rate value. So when we want the defined feed rate value and the linear interpolation with respect to the defined feed rate value, we are using G01. So G01 has to become with the letter F and the feed value here. So F here we have to mention 50. The meaning of F50 is that the feed rate is 50 meters per minute. Well, G00 means we are asking the controller to get the tool at X 1.7, Y 2.4. There is a start of the spindle, that is M03. The spindle has to be start in clockwise direction with speed of 900 RPM. Spindle will be made on with the speed of 900 RPM, and the tool will move to position X 1.7 inches, Y 2.4 inches in the rapid way with maximum possible feed rate, 100% feed rate value. Then the tool is approaching the workpiece. So when it approaches the workpiece, we have to compensate the tool length as well. So we will see the concept of tool length compensation in the coming slide. When we are using G43, we have to mention the register H01, that is the information about T01, the length of the tool T01. When the tool is approaching the workpiece, we are making the coolant on as well. So M08 belongs to the flood coolant on value. And when the tool comes to a safe position above the workpiece, then we are asking the tool to carry out the drilling operation. The drilling operation would be done by using a command, that is G81. It is the CAN cycle for drilling. So we will see the syntax of CAN cycle. The meaning of R, Z, F is the feed. As we are activated G20, that is input in inches, so naturally the F word would be in inches per minute. If it is G21, then the value would be in meters per minute. Now at the start, at the first location, the hole will be drilled, and that first location is 1.7 x and y is 2.4. So this is the location number 1 and its coordinates are 1.7 x and 2.4 along y. First hole has been drilled now. Now we have to move in upward direction. There are 1, 2, 3, 4, 5, 6. So 6 number of holes are to be drilled in upward direction in column number 1 after drilling the hole 1. So we will try to utilize a compact programming, as efficient programming. We will just specify by what amount we have to move in a upward movement along the length along the column 1. All the holes are equispaced along x-axis and along the y-axis. When the holes are equispaced, then we can utilize this facility. So here we need to just mention the distance between center of the holes and the number of holes. So distance along y direction is 2.1 and the number of holes that to be drilled are 6. So that information we will feed now. So for that purpose, now we are switching from the absolute programming to the incremental programming. So G91, the incremental programming is made on, and whatever the information, distance information we are providing now onwards will be in incremental mode only. We are moving with a distance of 2.1 inches in y direction. So that's why y 2.1, K6, K is the number of holes that to be drilled. That information is K6. Some controllers are allowing the letter L as well. So K or L, the meaning is same. 6 is the number of holes to be drilled. The controller will understand this block as in incremental mode from its previous position. What is previous position? From x 1.7, y 2.4, we have to move along y direction with a distance of 2.1 for how many times? For 6 number of times. So after reaching this point, this is hole number 2, 3, 4, 5, 6, 7, then the hole number 8. From 7 to 8, we have to move along positive x direction. So 7 to 8 is positive x by a distance of 1.8 inches in incremental way only. So G91 would be on for the duration till which we are saying that no need to go back to G90 command. So positive x with a distance of 1.8 inches. So that information we will write here. We are simply writing x 1.8. So when we are writing x 1.8, the tool will go to x 1.8 and it will carry out the drilling operation at this location. Its y position would be the same. We need not to mention the y position once again. So when we are not mentioning, when we are not repeating the information for certain G codes, that G codes are called as the modal commands. For example, G91. We have made the G91 activated in block number 10. In 11, 12 onward, we are using the information in incremental mode only, but we are not repeating the word G91. So it will consume the space, it will consume the memory space, and that would be redundant. So there is no need to make G91 written for the subsequent rows unless and until we write G90 somewhere in the subsequent rows. That you can see in the block number 19 when we are switching from 91 to 90. So unless and until you write G90, the G91 would be considered by the controller X 1.8, that the whole number 8 would be carried out. So from whole number 8 we are moving in downward direction, we are moving in negative y direction. So from this position we are moving along the negative y direction for how many number of holes? 1, 2, 3, 4, 5, 6. So 6 number of holes, but the distance is not positive, it is negative. So that information we will write here. So we are moving in negative direction along y by a distance of 2.1 inches, and the number of holes are to be drilled 6. Again we are following the same procedure. We are moving in positive x direction and we are asking to drill the hole for column number 3. So this is the column 3 start point. Then the column 3 would be processed. We are asking the controller to move in positive y direction by a distance of 2.1 and drill number of holes as 6. Then move in positive x direction by 1.8. So this is the column 4 start point. So after the drilling hole, we have to complete the column 4 drilling. Y minus 2.1 in downward direction, negative y direction, number of holes to be drilled are 6. Then we are moving to the column 5. Column 5, we are asking the controller to move in positive x direction by 1.8 inches, and then we are completing the column 5 by asking the controller to move in positive y direction by distance of 2.1 and to drill number of holes are 6. So after completion of all this drilling of holes, we are switching the mode from G91 to G90. G90 has been activated. All the cycles would be cancelled. So here we are using the cycle, the CAN cycle G81, that will be cancelled, that is G80, and we are making the coolant off. So here the coolant off would be done by using M09. Afterwards, we are asking the controller to take the tool to its home position by using the preparatory code G28, and it will travel through a certain point. These are the safe point in the work volume, and these safe points are Z10, X0, Y0. When the tool is traveling through this point, it will not hit, it will not interfere with the geometry of the tool. So G28 means we are asking the tool to go to the home position via these points, and M05 belongs to spindle stop. So we have to make the spindle stop. At the end we are writing M30, that is end of the program, and at last we are writing the percentage sign. So in this way the 35 number of holes would be drilled. So now here the question comes, what is the meaning of G92 and how to set the G92? Then we have seen that there is one concept, that is tool length compensation and the meaning of CAN cycle. So this we will see one by one. Well, the meaning and significance of some of the initial blocks can be seen on your screen. Block number 1, 2, 3, 4. Already I have discussed these blocks with you. The block 5, which is setting the program 0 of the work part. In CNC machine tools, basically there are 3 environments of the programming, and we need to have establishment of mathematical relationship between these 3 environments. The first environment is the machine tool and its own control system. That is a tool unit which is having the holder and the cutting tool. And the third is the part. So part is the workpiece, its drawing and the material. So we need to have a communication between these three units, these three sections, and we should establish the mathematical relationship. The success of the CNC part programming is dependent upon that relationship only. So let us first understand the machine reference point or the machine control volume. Well, let us understand the concept of machine zero point. So as I mentioned, each and every machine tool is having its own work volume and it's having its own reference point. In general, the reference point is considered as to be located at the end of positive ranges of x, y and z axis. So each work volume is having x, y and z axis. Each work volume we are considering as a cuboidal with three dimensions x, y and z. So here let us consider that we are having the x, y and z. On CNC machine, the machine reference point is located at the end of positive ranges. So if I move along the positive x direction at its end, so here its end. In a similar way, if I move along positive y direction, so at this point, if I move in a positive direction, so here I will reach. Now I have to move in positive z direction. So I'm moving in positive z direction and then I will reach this point. And this is called as the machine zero point. Our work part would be located inside the work volume anywhere. Consider our work part is located here itself. This is the work part. Now we know the dimensions of the work part. We are trying to make features on the work part, but the machine reference point is located somewhere else. The machine knows its own reference point. It does not know the part zero. It does not know the dimensions of your part. So we need to communicate. We need to tell the machine control unit where exactly the part is located inside the work volume. This is the work volume. So the part may be at this location, or you may have the part at this location or anywhere in the work volume, but it is very essential, it is mandatory that we need to communicate the location of the part inside the work volume with respect to the machine reference point, because the CNC machine tool only knows about the machine reference point. We need to communicate the distance of the machine reference point with respect to the part reference point. So the way the machine is having its own reference point, the part is also having its own reference point. The more clear picture is there in front of you. So here you can see the top view. This is the machine table over which we are having the work part, and this is the machine zero, which is located at the center of the spindle. This is spindle center line. Here the machine zero is located. So this is the positive z direction. This is positive x direction, and here it is the positive y direction. So at the end of the ranges of positive x, y and z, the machine zero axis is being set. So here we are mounting the tool as well. The cutting tool will be mounted. This cutting tool is mounted in this way. We are communicating the length of the tool to the MCU as well. We need to provide the information about the cutting tool, its diameter and length. So the length is designated by the letter H and the diameter is designated by using the letter D. So D01 and H01. The 01 is the number of the tool, cutting tool T01. So tool number 01 is having diameter with respect to the 01 and length with respect to the 01. So these are the register values in the machine control unit. The operator has to manually feed these values. So we have to feed these values D01 and H01. These are the constant values that need to be fed essentially. In a similar way, you have to feed the values for the tool T02, T03, so on and so forth. As I mentioned, we are having our own part 0 setting. So we know the geometry of our part, we know the locations of the features. Consider a hole to be drilled, or there is another hole to be drilled, or we may have a slot that to be machined, or some pocket is to be milled. So many features to be machined on the work part, and we know the location of these features with respect to the program 0. So in CNC part programming, we have to fix the program 0. So here the program 0 has been taken at the lower left corner of the geometry on the top surface. On the top surface, the lower left corner has been selected for the program 0 setting. So it is not essential that you have to set this point, but this is more convenient. You can have the program 0 sitting at the center point as well. With some programmers, they may utilize the center point of the geometry itself as the program 0 setting. If the geometry is circular, in that case, we are using the center point of that circular geometry as the program 0 setting. So part reference point is also called as the program 0 or part 0. Many a times the program 0 setting has been done on the fixtures. When we are machining the components in multiple numbers, then we are setting this program 0 to the fixture. The fixture is fixed on the machine table. We are just changing the part, but the part setup should be very accurate with the fixture. So if there are errors in the part setting, that would reflect in the accuracy or the product accuracy. Now, how to carry out the program 0 setting? So as I mentioned, each machine is having its own reference point. So this reference point is known to the machine tool, and in addition to this reference point, we are adding the cutting tool. The cutting tool is having the collet, or it is having its holding unit and the cutting tool. So this information is to be fed, is to be entered inside the MCU, and with respect to the tool tip of the cutting tool, we have to set the offset distance with the cutting tool tip and the part. So here, to carry out this exercise, we are using a command that is G92. So here G92 is having three information that to be entered: X distance, Y distance and Z distance. So what is the meaning of X, Y and Z? So let us consider that the table is having the part which is fixed on the table. The part is having its own axis X, Y and Z. Now the machine knows this point and machine is having the information about the cutting tool as well. Now we need to give the information to the machine tool that the distance of this point from the origin of the part, distance of the machine 0 point from the origin of the part. So how to get this distance? To get this distance, we have to move the table and we have to match, or we have to coincide the part 0 with the machine 0. The part 0 is here and the machine 0 is here. We have to coincide them. We have to take them together. We can't take them together because we are having the cutting tool. So what we are doing here, we are trying to touch the cutting tool on the top surface at the program 0. We are taking the cutting tool to the program 0. So to take the cutting tool to the program 0, we have to move the table. So we are moving the table in positive x direction. We are moving the table in positive y direction, and we are taking the tool in negative z direction. So move the table in positive x, move the table in positive y, or move the cutting tool in negative z direction. So when the tool tip is touching the part 0, whatever the values are shown on the display of the machine tool, the machine tool display or the GUI of the machine tool will give the value of x, y and z. So these are the offset values from the tool tip to the top surface of the part at the origin. So these XYZ values are to be manually recorded, and these XYZ values are to be entered here. So this is very essential, very important function of the CNC part programming, that is a G92, in which we are feeding the accurate information about the offset between the program 0 with respect to the machine 0. So whatever the distances will be communicated later, that distances would be taken care by the MCU by adding these offset values. So the controller will understand that it has to reach to the program 0 by adding XYZ value, and from this point onward it has to carry out the operations as per the instruction given by the programmer. So as the parts are getting changed, the part program reference points locations are also getting changed. So we need to do this activity regularly for each and every part. So if the fixture is fixed, if the reference point of the fixture is fixed and we are not changing the setting, then we can reduce the part setting time tremendously. Well, the meaning and significance of the next blocks can also be seen on your screen. So the block number 6 and 7 I have already discussed with you. So here we have to switch on the spindle with 900 RPM, and we have to approach the position Z rapidly. And then we need to carry out the tool length compensation by using G43 command. So let us look at the meaning of the tool length compensation. The tool length compensation is a very important preparatory function or preparatory command which is setting up variety of cutting tools in CNC part programming. Now during the G92, as we have seen that we have to enter the values of X, Y and Z. Now let us consider we are setting up this G92 with respect to the tool 1. This tool 1 is having length 1. What we are doing here, we are trying to take the tool tip to the top portion of the workpiece. So to take the tool tip to the top portion, the tool tip is traveling a distance of z1 in negative z direction. The distance of machine 0 point is the length L1 plus Z1 from the top portion. But consider, by using the command M06, we are trying to use tool number 2. When we are switching tool number 2, which is having length L2, where L2 is more than L1. So in this case, we have set the machine 0 part 0 relationship with one tool, and now we are changing to the another tool. So it would be time consuming and not appropriate to use G92 once again for tool number 2. So for that purpose, we have to communicate about the difference between the length of the tool L1 and L2 to the machine tool. So that is called as the tool length compensation. So L2 is more than L1. So we have to communicate the distance L2 minus L1 to the MCU, but this distance has to be compensated along which direction. So that is dependent upon the tool that we used for G92 command. So consider we have set the G92 with the shorter tool. T1 is the shorter tool. We have set the G92 with the shorter tool. So Z1 is the distance that tool tip has to travel to reach at the top portion. But the L2 is more than L1. So the distance of the tool tip of T2 from the top portion Z2 is less than the distance Z1. So shorter distance that tool tip has to travel from this point to this point. If I don't utilize any compensation, the machine control unit will follow the instruction. It will take the default value as the Z1 that to be travel, and it will hit and it will interfere or collide the work part, and the machining will be failed. There may be catastrophic failure of the machine tool itself. In this case, we have to tell the tool tip of tool 2 to move in upward direction, in positive Z direction. We have to take the tool tip of 2 to the tool tip level of 1. So this level has to be matched. So this is the level for level 2 and this is level 1. So level 2 has to reach to level 1. So for that purpose, we have to take the cutting tool in an upward direction. For that purpose, we are using G43 command. So tool length compensation along the positive Z direction. Now we are setting the G92 with respect to the longer tool. So T2 has been considered for setting up the tool for the longer tool. Then the tool tip of 1 has to travel the distance of Z1 minus Z2 along negative Z direction. So Z1 minus Z2 in negative Z direction. So when the longer tool is used for G92, we are using G44 command, that is tool length compensation along negative direction of Z axis. Well, let's go back to the program and see how this G43 has been utilized in our case. Here you notice that we are asking the controller to get the cutting tool at X 1.7, Y 2.4 location in rapid mode. So from home position, the controller will come to X 1.7, Y 2.4 in a rapid way, that is a G00. But it is at a considerable distance from the top portion of the work part. So it is just moving in the XY plane, it is not moving in the Z plane. So once the tool reach to X 1.7, Y 2.4, then we are asking the tool to travel along Z direction and reach at a point 1.0, which is above the top portion along the Z direction. When the tool is traveling from the safe position to the reference position above the work part, we are asking the controller to activate G43, tool length compensation along the positive direction. So we are assuming that the part 0 setting has been done by using a shorter tool than the tool number T01, or it is done by the shortest tool among the tools available in the magazine. So when it is approaching Z is equal to 0, that is a reference plane, the safe distance, it is utilizing the value of H01, the length of the cutting tool would be considered when it is approaching the Z level, and it is making the coolant on M08. After reaching to the reference position, Z position, then we have to carry out the drilling operation. So to carry out the drilling operation, we are using a cycle, that is the G81 cycle. So in general, we are following the standard steps to drill the holes. The tool is approaching to the destination, but in a safe plane, the plane which is at a considerable distance from the top portion. So this is the top portion. It is Z is equal to 0. So this is Z is equal to 0. This is the axis Z, X, and this is Y. Our program 0 has been set on the top portion of the work part. Now we are calling the tool in a rapid mode. So dotted lines are rapid. The tool will come to the destination in safe plane, rapid way. Afterwards, it is approaching the desired position. So let us consider at this position, the tool has to carry out the drilling operation. So when it is approaching the top portion of the work part, that approach may be converted into two modes, that is the rapid mode and the feed mode. Rapid mode would be activated, would be used to improve the productivity, to do the faster operation. Let us consider there are 100 number of holes to be drilled, and the distance from the tool tip in the safe plane to the work part, it is at a considerable distance, it is significant distance. If we can save around 2 seconds or 3 seconds to approach the work part, the 100 number of holes will save that much of time. We are trying to utilize the rapid mode as much as possible, but at certain point we have to stop, we have to change the rapid mode to the feed mode. So suddenly we cannot come and do the work operation in a rapid mode. We have to come to the R level. This is the R level, reference level, and this is the initial level. So from initial level to the reference level, we are coming in a rapid mode, and from the reference level, we are asking the tool to carry out in the given feed mode. So this is Z00 and this is Z01. The tool has gone inside, it is carrying out the drilling operation, it will complete its operation, then it has to retract. So retraction would be done using G00 in a rapid mode. So here also it is to be done 00, that is in the rapid mode. So we are carrying out the drilling operation in the feed mode, but the retraction would be done in the rapid mode. So this is a typical cycle. These are typical operations of a particular drilling cycle. These entire operations are written in a compact way by using a syntax, and that syntax can be seen on your screen. The syntax is having variety of words. The first word is G98 or G99. G98 or G99 has to be specified. The word G81 designates can cycle for drilling operation. X and Y are the coordinates of the point at which the drilling operation need to be carried out. R is the distance of the reference level from the top portion. This distance of the reference level from the top position that we need to specify. Z is the depth of the hole that need to be specified, this distance. This is, if it is a through hole, then it is the thickness of the plate. So this would be the thickness in case it is through hole, and F is the feed. Now here the question comes, for the retraction, where to come at the initial position or to come at the reference position. Both these positions are fine, but we need to choose one of these for our application. So let us consider in our case that we are having a plane geometry, a flat geometry, and all the holes are to be drilled in this manner. So the tool will come and it will drill a hole here, then we have to move to the next position and it has to carry out the second operation, then third operation. So in this case, when the geometry is plane and with no need to get the tool back to the initial position because that will consume a lot of time. So for that purpose, we are asking the tool to come to the reference level, and from reference level, it has to go to the next destination in a rapid way. So when such information is to be passed to the machine control unit, we are using G99. So the text would be G99, G81 and the other operation. When we are saying that the geometry is plane and it has to just pass as fast as possible. But in certain case the geometry is not plane, it is having some towers as well, and here the drills are to be made, and the reference position is this and the initial position is this. So this is the initial position and this is the reference level. So in this case we are asking the tool to come at this position and then come in the rapid way to this position and then carry out the drill operation. If we are using G99, the tool will move in a horizontal direction and it will collide the towers. So for such thing, we are asking the tool to go to the initial position, that is the safest position, and then move to the next destination in this way. So for such operations, when the geometry is not planar, we have to go to the initial level and then we have to carry out the other operation. So for that purpose, we are using the G98. So we have to use G98 and G81 in the situation shown over here. Or let us consider that we have to change the tool. The drilling has been completed, then we have to do the spot drilling operation or countersinking operation. So for that purpose, we need to change the tool. So in that case as well, we need to go to the initial level and then we will be asking the cutting tool to go to the home position. So for that purpose as well, we are using the G98 command. Now let us come back to our code. Here we have written G99. We are trying to move in the reference position. G81. The reference position is 0.1 inches above the top portion of the workpiece, 0.1 inches. The depth of the hole is 0.4 inches, that is the thickness of the plate, and we have to carry out the operation with F is equal to 3.03 inches per minute. So in this way the first drill would be carried out. Later we need not to repeat this command, that is G99, G81, this complete block need not to rewrite again. This is modal. G81 is also a modal command. We are not specifying the G81, henceforth whatever the spots, whatever the locations are given, the controller will go to that location and will carry out the drilling operation. So in this way, we are writing the part program for drilling operation efficiently. This programming we are carrying out by considering the FANUC controller. The G and M codes which are provided in this lecture are according to the FANUC controller. As I mentioned, there are other controllers such as Sinumeric, Mitsubishi, and many other controllers. Before we study the contour finishing programming, let us look at the meaning of the various blocks from block number 10 to block number 16. Already we have discussed these blocks at length during our discussion. Please read these blocks and refer for the further programming application. The next set of blocks, that is block number 17 to block number 23, are there in front of you. Well, let us go for the next application of CNC machining center, that is contour finishing. Contour finishing means we have already got a contour and we have to just finish that contour. We have to remove the machining allowance which is provided. Consider a casted plate which can be seen on your screen. This is the casted plate. This casting is having a machining allowance of about 2 mm. Extra material is there 2 mm, and we need to just remove that 2 mm to get the perfect corners and perfect surface. So on your screen you can see a casted plate. It is made up of mild steel. The thickness is 20 mm. It may have variety of features such as we can drill number of holes of various sizes by using the PTP programming which we have seen in our previous slides. So for drilling we are using the PTP, that is point to point programming. However, now we will be studying how to get the required contour by using CNC finishing operation. So the machining allowance is 2 mm and we have to just remove that 2 mm machining allowance from the work part. So to carry out this operation, we have to first develop the process plan. In this case, there is only one operation, say the contour finishing operation. We have selected end mill whose number is T01. It is having the length, certain length, and that length has been entered inside the register H01. The tool diameter is entered into the register D01. If we are adding the drilling features as well, or we are adding certain other features, say the form machining features, then we can add these operations after the contour finishing, or even we can change the sequence based upon the optimization, based upon the convenience of the user. Before starting to write the CNC part programming, let us finalize the tool path. To finalize the tool path, first we are selecting the program 0. So let us consider that this is our program 0. So this is X, Y, and this point is 0, 0. All the dimensions are in metric. These dimensions are in mm in metric system. Now when we carry out the contour finishing programming operation, the controller has made our life very easy. We have to just program the points of the contour. We have to give the information about the points along the contours and the required interpolation function, and the controller will automatically compute the cutter location point. So we are providing the contour points that will be converted into cutter location point. But to consider the cutter location point, we have to add here the diameter of the tool. Now, as per the syntax of the CNC part program, we have to give the information about these points only. So let us first find out the number of points which are to be communicated to the part program. So this is point number 1, 0, 0. So this is point number 2, P2, this is P1, this is P2. So P2 is 0 and Y is 110, that is 110. This point is the P3 point, is having coordinates x15 and the Y coordinate is 125. So from P2 to P3 we are moving in clockwise direction, and that is the circular interpolation. So from P1 to P2 we are moving in linear interpolation. So this would be Z01. From P2 to P3 it is G02, circular interpolation in clockwise direction. Then we are trying to find out the coordinates of this point P4, P5, P6, P7, P8 and coordinates of P9. Then we will get the coordinates of P10, P11 and it will reach to its destination P1. So from point P8 to P9 the controller is carrying out the relative motion in anti-clockwise direction. Here also the motion is circular interpolation, but it is in counterclockwise direction or anti-clockwise direction, and that is G03. So after getting the coordinates of all these points on the contours, then we can start doing the programming. But here the important concept which is coming, that is the cutter radius compensation. So as I mentioned, we are communicating the controller the contour points, and these contour points are to be considered with the diameter of the cutting tool. So if we don't communicate about the diameter of the cutting tool or the compensation of the diameter with respect to the contour, then the controller will move the cutting tool along the contour path and that will destroy the workpiece. For example, in this case, if there is no cutter radius compensation, so this is the initial tool movement, and as we are asking the tool to move along the contour, then it is moving with the center point of the tool at the origin. The center point of the tool will be at the point P1. With the center point only, the tool will move along the tool path. Due to this, there would be overcut of the contour. Since we are not considering the diameter during the operation, there would be overcut by the radius of the cutting tool on the work part. So if we don't offset, if we don't communicate the diameter that to be considered along the left direction, what will happen? The tool will move in this direction and there would be overcut by radius value. So to tackle this problem, we have to compensate the radius compensation. So to activate the radius compensation, we have to give some margin during that margin period, during that margin distance. The controller will take the tool, it will activate the cutter radius compensation. So for that purpose, we have to take the tool not exactly at 0, 0 when we start writing the program. We have to take the tool to the safer position. Safer position would be along the negative x direction by say 20 units and negative y direction by 20 units. The safe position would be here. So this is initial tool position that we are considering minus 20, minus 20. Now we have to start carrying out the operation that we call the ramp on and ramp off operation. Now let us see what is the meaning of this ramp on and ramp off. So the concept of ramp off is in connection with the cutter radius compensation. So as I mentioned, we are taking the tool to the initial position, that is minus 20, minus 20. On approaching the point P1 from the safe position, we are activating a command, that is the cutter radius compensation. And the first cutter radius compensation command is G41, that is we have to compensate the cutter radius towards left. So as we have seen that we are approaching, our path is from P1 to P2, then P3, P4. In this way we are moving the cutting tool along the contour. Now when we are approaching the contour, we have to take the tool in a such a way that its edge will in contact with the contour. Its center point should not be on the contour. Its edge, its outside edge will in contact with the contour. The contour will be tangent to the cutting tool. So to do that, we are approaching the initial point P1 by taking the tool from initial tool position minus 20 to this point, and when we approach this particular point, let us say it is P1A, this is P1A point. When we are approaching to P1A, we are activating G41. When we are approaching from initial position minus 20 to P1A, the tool center will not come at this point. It will be offset by the tool radius towards the left of the path of travel. So the path of travel is this, and we are asking the cutting tool to move towards left direction. So that is called as the cutter compensation towards left. So with G41 activation, the cutting tool will come and the contour would be tangent, and then we are asking to march along the path P1, P2, P3, P4, so on and so forth. The approach of the cutting tool from the initial tool position to point P1A, it is called as ramp on, and further from P1A to P1. So from P1A, we are asking the cutting tool to carry out the machining operation, although there is no cutting would occur from minus 20 to 0. So for 20 mm, although the tool is moving with a given feed, there will not be any cutting will occur. This is for the safety of the workpiece. So there would be gradual engagement of the cutting tool with the contour of the work part. Now from P1A, the cutting tool will come to P1, then P2, P3, P4, and at last it will come at P11. From P11, the cutting tool has to come out from the contour loop. Instead of stopping the cutting tool at P1, we are asking the cutting tool to move out of the contour loop, that is called as ramp off. The meaning of ramp on: you approach the contour with cutter radius compensation on in safe mode, and to come out from the contour by completing all the operation without leaving any uncut portion from the contour by a distance of minus 20 along the x direction. Along the x direction, it is the air distance with the given feed, but that will ensure the perfect corner at P1 point. So the ramp off will ensure the safe exit of the cutting tool and the better accuracy or the exact machining of the corner. So in this way, the ramp on and ramp off are to be considered along with the cutter compensation methodology. So let us move ahead and look at the program. So this is the start of the program, that is a percentage sign. Then the program ID is given here. G21 is designating input in millimeters. This is input in millimeters metric system. Then we are providing the usual cancellation cycles such as G40, G80, G49, and we are activating G90. G90, as you know, it is absolute programming. Then we have to set the program 0 by using G92. We are selecting tool T01. We are changing the tool by using M06 with the existing tool in the tool spindle. Then we are coming to the initial tool position, but we are at a significant distance from top surface of the tool plate. So we have not yet reached proximity to the tool plate. In XY direction away from the tool plate, we have reached the initial tool position, that is X minus 20, Y minus 20. Then the tool length compensation, Z10 is the reference level above the workpiece surface. H01 is the length of the cutting tool, and M08 is the coolant on. We are making the coolant on, and then immediately we are starting the spindle as well. M03 with a speed RPM of 1000. M03 designate the rotation in clockwise direction. Then from the safe position, we are taking the tool in negative Z direction with the given feed. So G01 F50, it is in meters per minute. So with F50, the tool will travel and it will go to Z minus 20. Note here that the tool will not in contact with the workpiece because it is at minus 20 initial tool position. Now as the tool has reached to the initial tool position, now it has come in proximity to the work part as well. Now we have to do that ramp on operation. During the ramp on operation, we are activating the cutter radius compensation towards left. We are approaching the initial point, the first point of the contour, that is the point P1. This is point P1 will be approached with diameter D01. The controller will understand that it has to move towards left by a distance of D0 divided by 2. So the diameter divided by 2, by that radius it has to move towards left to get the exact contour. Now we are reducing the feed. Actually we are starting the cutting operation, so we are working at a moderate feed, that is 25 meters per minute. Now we are starting the programming of the contour. From point P1 we are going to point P2, then point P3, P4, so on and so forth. So here we are just mentioning Y110. G01 is activated, so G01 is a modal command, so there is no need to write here. But now this is the circular interpolation. From linear interpolation to the circular interpolation we are changing, so we have to write G02. But G02 is only for a small contour that we have seen. From G02 again we are switching to G01. We will program the contour points as you can see on your screen. These are all the contour points. Now from this contour point we have to exit the tool has to exit from the contour safely, and that is called as the ramp off. So this is ramp off, and after ramping off it has to reach to the safe location, that is G01 Z10, above the top portion of the workpiece by 10 mm of distance. Then we have to switch off the spindle, we have to switch off the coolant, and afterwards we are asking the cutting tool to go to the home position via X0 Y0. There is intermediate point we are providing. We are asking the cutting tool to pass through the point X0 Y0, and at the end the program stop. This program also we have written by using the syntax related to FANUC controller only. The meaning of the blocks and their significance are there on your screen. So block 1 to 5 are the preparatory instructions, then 6 to 7 are the selection and change of the tool, that is T01. Block 8 belongs to the tool length compensation, then spindle on. Block 10 and 11 are providing the information about the approach and the ramp on operation. As I mentioned, our case was this G41. So this is the contour, and we have to move away from the contour towards left direction. So G41. If the case is the other way, that we are moving in downward direction, when we move in a downward direction, the contour is on the left direction, so the compensation is towards the right of the travel direction. So for that purpose, we have to ask the controller to move away from the contour in the right direction, that is G42. So if we don't utilize the compensation, the cutter will move in this direction, and this would be the overcut, and that will spoil the entire work part. So here the same way has been shown over here. Now the contour is on the left side, and we are moving from bottom to top. The radius compensation is along the right direction. When we are moving in a downward direction, the compensation is towards left of the tool path. If nothing is done, then there is overcut. 12 to 21 are providing the information about the interpolation. Block 22 is providing the information of the ramp off, and from 23 to 26 there are program end instructions. So in this way we are finishing up the part programming, which is very important aspect as far as the automation in manufacturing is concerned. Thank you. So let me summarize, my friends. In this lecture we have seen the basic concepts pertaining to the CNC programming. We have seen the meaning of G and M codes. So variety of G and M codes are used in development of the CNC programs for milling and turning operations. We have seen the structure of a typical CNC program, various functions such as scan cycles, tool length compensation and tool radius compensation. At the end of the lecture, we have solved certain examples, we wrote certain programs, and we understood how to develop a typical CNC part program. So with this, I would like to say goodbye to all of you, and I thank you all to listen to these videos and give a very good feedback to the course. So thank you all.